Good afternoon to all. I am D. Suresh, working as Assistant Professor, Computer Science Engineering, PSNA College of Engineering and Technology. Today I am going to discuss about scheduling algorithms in operating system. Scheduling algorithms. In the scheduling algorithms, totally different algorithms are there. First one is the first come first serve. Second one, shortage of first scheduling. Third one, priority scheduling. Fourth one, round robin scheduling. Fifth one, multi-level queue scheduling. Sixth one, multi-level feedback queue scheduling. Okay. So first one is the first come first serve. First come first serve. It will follow the allocate the CPU based on the which process require the CPU. On first come first serve. So first come first serve, which process requires the CPU enter in the queue, that is allocate the CPU first. Okay. It will follow the first in first out, which process enter the queue, that is allocate the CPU first. Here there is no preemptive concept. Then an example. So in this one example, for the three process P1, P2, P3, the burst time of the P1 is 5, burst time of the P2 is 6, burst time of the P3 is 7. Okay. Now for this we can draw the Gantt chart, find the waiting time and turnaround time. So for the drawing Gantt chart, so Gantt chart means it represents the starting and ending time of the every process. So it is like a bar chart. Gantt chart is a bar chart. It represents the starting and ending time of the every process. So Gantt chart for this example. So here first process is the P1, that is enter in the queue. So first allocate the CPU for the P1. So starting of the P1, so burst time is 5. Then next one is the P2 enter in the queue. So then allocate the P2 for the CPU. The time is 5 plus 6, 11, then P3, 11 plus 8, 7, 18. So this is the Gantt chart for the first come first serve example. Now find the waiting time of this one. Waiting time means how much time the particular process waiting in the queue. So waiting time of the P1 is 0, waiting time of the P2 is 5, waiting time of the P3 is 11. Now average waiting time, add the three values and divided by 3. So 0 plus 5 plus 11 by 3, 16 by 3, so 5.3 milliseconds. So this is the waiting time of the first come first serve. So turnaround time means it is the in time interval between the submission and starting of the next process, that is a turnaround time. The turnaround time formula is waiting time plus burst time of every process. So P1 turnaround time is waiting time of the P1 is 0, burst time is 5, so turnaround time is 5. P2 waiting time is 5, then burst time is 6, 11. P3 waiting time is 11, burst time is 7, so 18. So this is the turnaround time for the first compressor. Average turnaround time 5 plus 11 plus 18 by 3 34 by 3 11.3 millisecond. It is the turnaround time for first compressor. So in the first compressor, the waiting time is large compared to the other algorithms. So next we can discuss the shortage of first scheduling. Second one, shortage of first. Here allocate the CPU, which one is the smallest job, that is allocate the CPU first. So in this one, shortage job is contains the preemptive and non-preemptive. It contains two types, preemptive and non-preemptive. Preemptive means that is which process is the largest priority, that is automatically enter in the queue, that is preempted by the running process. But non-preemptive, running process allowed to continue running entire burst time. Then the compared to the first compressor, the shortage of first waiting time is low. Time low. Now we see the one example. Process P1, P2, P3, burst time so in the P1 burst time is 4, P2 burst time is 3, P3 burst time is 5. Now in this in the given process, which one is the smallest job? P2 is the smallest job. Now draw the Gantt chart for this one. So first allocate the CPU for the P2 3, then allocate the CPU for the next highest burst time is P1, so 7, then final one is the P3 12. Now find the waiting time for this one. Waiting time for the P1 is 3, waiting time for the P2 is 0, waiting time of the P3 is 7. Average waiting time, average waiting for time for this one is 0 plus 3 plus 7 by 3, 10 by 3, the 3.3 millisecond. So now this waiting time is compared to the first compressor, this one is a very less. Now turnaround time for this, turnaround time formula is waiting time plus burst time. So P1 waiting time is 3, burst time is 4, so turnaround time is 7. P2 waiting time is 0, burst time is 3, so 3. The P3 process waiting time is 7, then burst time is 5, total one is 12. So average turnaround time 7 plus 3 plus 12 by 3, 22 by 3, 7.3 millisecond. So this is the shortage of first. Next one is the next we can discuss the third one is the priority. So in the priority scheduling, we can every process associated with the priority, using the priority we can allocate the CPU. Here 0 is the highest priority, then last number is the n number is the lowest priority. So priority is allocated internal priority, then external priority. Internal priority means it is based on the memory level, time limits. So external means it is allocate the priority outside of operating system. So internal priority, external priority. Internal priority is based on the memory level, time. External is outside of the operating system. Now see the example for this one. So process P1. So in this one, every process associated with the priority. So P1 priority is 3, P2 priority is 1, P3 priority is the 2. Now draw the Gantt chart for this one. Gantt chart. So here highest priority is the P2. So first allocate the CP for the P2, 6. Then next priority is the 2. So P3 is the next priority. So 13. Then last one is P1, 18. So this is the Gantt chart for the priority. The priority is also contains the preemptive and non-preemptive. Preemptive and non-preemptive concept is available in the priority. So priority means every process associated with the priority of the process. So here 0 is the highest priority, last number is the lowest priority. So in this example, P1, P2, P3, 3 process and associated with the corresponding priority. This is the Gantt chart for the priority scheduling algorithm. Then now waiting time. Waiting time for the P1 process is 0, P1 process is 13, P2 process is 0, P3 is 6. Average waiting time 13 plus 0 plus 6 by 3, 19 by 3, 6.3 milliseconds for the waiting time of the priority scheduling. Now turnaround time. Turnaround time for the P1 process, turnaround time 13 plus 5, 18, P2 0 plus 6, 6, P3 6 plus 7, 13. Average turnaround time 18 plus 6 plus 13. 37 by 3, 12.3 milliseconds. So this is the priority scheduling algorithm. Next one is the round robin scheduling algorithm. Next one, fourth one, round robin scheduling algorithm. In the round robin scheduling, that is implemented, designed based on the time sharing system. Design based on the time sharing system. Here Q is act as the circular queue, ready queue is act as the circular queue. Then this round robin is work based on the time quantum. So time quantum is the small unit of time, small unit of the time. The round robin is similar to the FCFS, but here it is added the preemptive concept. Here added the preemptive concept. It is similar to the first compressor, it is added the preemptive concept. Now see the example. Process P1, P2, P3, burst time 5, 7, 8. Now Gantt chart for this. time quantum value 3 millisecond. So every 3 millisecond the particular process is preempted and next process is start to request their CPU. Now this follow the first come first serve. So first process is the P1, it execute only for the 3 millisecond. So remaining 2 millisecond is balanced for the P1, that is preempted. Then next enter in the P2, first 3 millisecond of the burst time is executed, then remaining 4 is balanced for the P2, then preempt by the P2, then enter the P3, P3 again 3 millisecond is executed, remaining 5 millisecond is balanced for the P3. Now this is designed based on the circular queue, then again go for the P1, then remaining burst time is executed for the P1, then P2, the P2 remaining is 4 milliseconds, for the 4 millisecond only 3 is executed, so remaining 1 millisecond is balanced for the P2, then P3, the P3 remaining balance available for the burst time is 5, so for the 5 only 3 is executed, so remaining 2 millisecond is balanced. Then now completed the 3 process, then again go for the first one. So P1 completed entire burst time, then P2 is only contains the 1 millisecond, then P2 is executed, then final one P3, so 2 millisecond is balanced, so 14. So this is the Gantt chart for the round robin. So the round robin is worked based on the time quantum value. Then waiting time. So in this waiting time is calculated, which P1 is where it is completed, what is the waiting time. So P1 is completed here, the waiting time is so here P1 is completed, last waiting time is 9 minus how many time is P1 is executed except first one into burst time. So here P1 is 2 times is executed, so here only 1 time is executed after the first one, so 1 into 3, so 9 minus 3 6, that is waiting time of P1. P2, here P2 wait last waiting time is 17 minus, so except first P2 is executed 3 times, so 3 into 3 9, 17 minus 9 8, P3, the P3 last waiting time is 18 minus, so except first 2 time is executed, so 2 into 3 18 minus 6 12, average waiting time 6 plus 8 plus 12 by 3, 20 by 3 6.6 millisecond. So then turnaround time, so turnaround time for the P1, turnaround time for the P1 is 6 plus 5 11, P2 8 plus 7 15, P3 12 plus 8 20 is the turnaround time for the 3 process. Average turnaround time for this process 11 plus 15 plus 20 by 3, 46 by 3, 15.3 millisecond. So this is the round robin process. So round robin process is work based on the time quantum value. Time quantum is a small unit of time. So every small unit of time, the particular process is preempted, then you leave the space to the next process. Okay. So this is the scheduling algorithm. So for totally scheduling algorithms are first come first serve, then priority scheduling, then next one is the shortage of first, last one is the round robin.